Okay, thank you so much. It's such an honor to be here. I'm Youssef Ossama Kinetic. I'm a founder of Printicon for Architecture and 3D Printing Solutions. It's a startup and TA at Arab Academy of Science and Technology, and also I'm a fresh graduate architecture. So it's my first ever research paper. So I'm really glad to be here. First of all, my research is about kinetic architecture. It's on a small project. It was held in University of Calgary under the supervision of Professor Nasser Hashimi in the geomatics department. I'm also one of the students of Ali Ibrahim, the one who made the second talk yesterday about hydromorphs. My research workthrough is first of all, I was studying and research about the kinetic architecture and study different designs and mechanisms, understand it, and then apply the research on my project. This project is a physical model that technically moves according to the light sensors. Linking the digital design with a physical model and then fabricate it, run this physical model, the simulation, and then analyze this facade on my graduation project. And then I design design and edit and visualize this kinetic architecture. Everything okay? And okay. So a simple concept of kinetic architecture is that the structure of a building can be move and not be static. This concept made from the medieval ages. It's not that new, but in these days, after the technology, it's kind of advanced now. Studying of one of the almost iconic researches projects. It's a Bahar Tower, studying the mechanism of the panels and how it works and how it moves to be able to make my project. Here's a small 3D model based on my research. That includes all the fixations and the servo motors that are moved by Arduino. Here's some sketches of the mechanism I made and the prototype of the panels, and see how it moves. I used the rhino grasshopper as a designing tool and simulation to control the servo motors using Arduino. This connection this connection of the Arduino with a grasshopper and my design applied with a Firefly plugin, which connects the Arduino and read the readings from the sensors, and then send it to the servo motors to based on the calculations or the numbers remapped to suit the rotation of the motors. And here's another plugin I used, so called OSC listener. OSC it's an application that I can connect the grasshopper with my phone, that I can control the facade using my phone as a horizontal point, and also here the administration of the servo motors moving with the rotary I'm using. And here's the example also why I'm using the light sensors to control the facade based on the intensity of light, the interior space required. And here's also the 4 different motors that are based on the light intensity. I also made a solar tracker that the track the most. Okay, sorry. Any problem with the chat? Everything is okay?
Yeah, it is okay. We can see everything.
Thank you. So this solar tracker, the body of it are made of 3D printing material. It consists of four photosensors that senses the intensity of light, and this cross is about is for making the shadows, so that the readings go towards the most intense light. And here's the fabrication of the physical model. I tried using a simple material. It's a foam board that I made the cracks, so it will be works as the hinges to be able to open and close. Okay, so this is some of the mechanisms I made. Here's the blind. I bought a blind from a store, and then make it so I can control it by myself. Here's the interior mechanism of the panels. Here's my while I'm editing the mechanism of the blind. And also here where I'm making the videos, the panels. Sorry if the videos are lagging because of the connection. Here's the last piece of the fabrication. Here's the fixations that are 3D printed. These fixations are 3D modeled by myself. And then after I fabricate it, I have to link the servo motors and the Arduino to my design, so I can make a simulation of the whole mechanism that it's working. Here's the mechanism that I'm testing the mechanism manually, not by the sensors. Just to make sure everything is going okay. These old hinges and fixations are designed and 3D printed just for this small project. And also this is the kinetic facade. Sorry, the blind. And here's the timeline of the facade working based on the intensity of light. I'm exposing the light on here. So it moves. It's a small scale, just to be good. And also, this is the blind. It's not working so well, but I had to make it so fast because I was going back home. And here's the final model of the small house and this different mechanisms of kinetic facade. Apply this research on my graduation project. It's a brief about it. It's a robotic construction research center that are based on that makes robotic construction for the new Alamein city. It's a shape like dunes that are generated like the cells. And here is some functions in the migration project that's a robotics 3D printing in different ways. Here's the 3D printing on surface and the ordinary 3D printing. It's not the topic of. Okay, so this is some diagrams, detailed diagrams about the kinetic facade on my graduation project. And then I analyzed the facade based on the solar path, and see the effects of the panels based on where the sun is going, or the intensity of light of the interior, the intensity of light or lux needed for the interior spaces, and here's some solar radiation analysis on the facade. This is the radiation for the whole year on the floor plan of the interior with and without the kinetic facade, and also the sunlight hours analysis that makes see the difference between the with and without the kinetic facade. And here's the edit and design and visualize the facade in VR. I was using software called Mindesk that links Rhino and Grasshopper with Unreal. That can use it as a tool. Here's some footage of my graduation project while using Mindesk. Here you can see that I can control the grasshopper inside the VR and control the kinetic facade. Here's you can see some lag because the definition was a little bit heavy. I'm working on it to be lighter, to move smoothly in the VR. And we can see it lagging in the Rhino interface. And also you can send the grasshopper definition to Unreal, so to be visualized in real time. This is a very interesting software that you can also visualize it in VR, so you have the full experience of the user, that you can see the shadows and how the facade is interacting, and you will be fully immersed inside the VR. And here's a video of the Mindesk in their YouTube channel. They are demonstrating how it's working in Unreal. It's not my work. I'm working with Mindesk on a project. It's the same project. It's the same video, but in a larger scale model. Here you can see the interior shade and shadows that you can interact and see how the final product will be as much as possible, because it's fully immersed inside the VR, and the client or the one who you view the research to, he wants to see the final product of the of his project. So as a conclusion, based on the steps I walked through, I can simulate the facade physically on a physical model, simultaneously using these tools to visualize it in Unreal. So sorry, in virtual reality. So the user can be fully have a full knowledge about his project or his facade while see the physical model moves and also the virtual reality. The really cool thing that's that parametric modeling really helps in this project, and also in the kinetic facade design. It's all about this project is all about for myself, at least, to know all of these things. It's not that new thing, but only for me to know how it works by myself. So thank you so much. And here's my my email if anyone further questions. Thank you so much.